Hello everyone, today we are presenting the project Historical Event Narrator, where we fine-tune LLMs for counterfactual storytelling by using LoRa. I'm Keerthirajan and joining me are Prithvi and Roshini. History is fixed, but storytelling doesn't have to be. Modern LLMs like GPT-4 are optimized for factual correctness, which makes them struggle with creative what-if scenarios unless heavily prompted. Our goal was to create an AI model that can narrate real historical events and introduce meaningful, imaginative, counterfactual twists automatically. This can help educators, writers, game developers, and creators build engaging alternative histories. And to achieve this, we need to build a specialized model on a student budget. So we chose Mistral 7B version 1 as our base model because it's open weight, powerful, and suitable for customization and available in Hugging Face platform. For fine-tuning this model, we used LoRa, which allowed us to adapt the model efficiently without needing the expensive hardware. Everything was trained locally on a M4 Pro processor using the Metal backend. Now Prithvi will walk you through how our end-to-end data pipeline works.
Our process begins with data sourcing. We scraped around 1200 Wikipedia articles covering major historical events. We then used Gemini 2.5 Flash to transform each factual article into a pair of a narrative retelling, a creative what if twist. This generated a clean JSON-L dataset ideal for fine-tuning our model. Finally, we trained the LoRa adapted Mistral model and deployed it inside an interactive Streamlit app. Our goal wasn't just storytelling, it was creative storytelling. Here's how the transformation worked. We gave Gemini an input like the fall of Rome, and it produced a dramatic narrative, a counterfactual twist like what if the Visigoths allied with Rome? Repeating this 1200 times gave us enough variation and richness to train the model to naturally generate creative narratives on its own. Next, let's look at how we actually fine tune the model locally. We trained everything locally on Mac M4 Pro with 24 GB unified memory because Apple Silicon currently doesn't support 4-bit quantization for MPs. We used torch.float 16 which balanced memory efficiency and speed. Our LoRa config was rank with 8, alpha with 16, 3 training epochs, total time around 3 hours. For software, we used Hugging Face Transformers, PEFT, and bits and bytes compatible setups. Now Roshni will explain the challenges we faced and how we solved them.
We faced two big challenges. First was out of memory crashes. The model frequently ran out of memory during interference. We solved this by manually clearing GPU memory using the empty cache method from PyTorch. The second challenge was hallucinations and mode collapse. Sometimes the model would finish a narrative and suddenly drift into unrelated topics. For example, jumping from an ancient Rome to the COVID pandemic. To fix this, we built an intervention strategy. Whenever the model started to hallucinate, we programmatically stopped generation and inserted a twist redirect prompt. This kept the story on track. So, we built an interactive Streamlit app where users can type any historical event and instantly get a narrative plus a twist generated by our fine tuned model. We also added an AI judge using Gemini to score creativity, twist quality. After fine tuning, our average creativity score improved from 2 to 8, showing a dramatic improvement. So we evaluated the model using ROG scores. It ensured the narration was good. We incorporated LLM as judge, which rated creativity, historical accuracy, and twist quality. Overall, the model is both factual and imaginative, which exactly we aimed for. Future work. So our project shows that even a 7B model can learn complex creative tasks when supported by high quality data. So next steps include expanding the data to 10,000 plus examples, trying 4-bit quantization for faster inference, improving twist diversity and long form storytelling. So now let's go ahead and see a quick demo.
Now we can see the demo of our app. So this is the web UI of our fine-tuned model, and on the left side, we can adjust the settings. For example, we can set the length of the narration, and here I'm setting it as 200, and we can set the creativity temperature for the twist. I'm setting the full score, and here we can enter the topic that we want the story about, and I'm going with the Hiroshima and Nagasaki story, and let's see what twist it gives. We have to wait for a few minutes because it takes time to load the model and let it to narrate the story and add a twist. Here we go. So this is the narration and the judge is working. So if you look at the narration, the first paragraph usually holds the factual content, and the second paragraph starts with the what if twist, and it goes with however imagine a different outcome. So in this outcome it says, what if the atomic bomb had never been dropped? So this story will have a different outcome with a different imagination, and it will really be engaging to read. So if you can see the judge score, so the AI judge has 3 parameters for score judging, and the first for creativity it says 5 out of 10, and the historical accuracy it says 9 out of 10, and the twist quality is 7 out of 10, and for each parameter it gives an explanation for why it gave that score. And this LLM as a judge adds a real value since each and every aspect is important. So yeah, that's it. That's our project. Thank you.